Good afternoon. My name is Brianne Peters. I am a DMP student at West Coast University. In this presentation, focus on the use of applied statistics in a Doctor of Nursing practice projects and an emphasis on infection prevention competency training. I will discuss how statistical concepts can be used to measure outcomes, evaluate interventions, and support evidence-based practice decisions that will help Aomer Chanel Metzball. I will also connect these concepts to my proposed DMP project involving infection prevention practices in a medical spa setting like Aomer Chanel Metzball here in Killeen, Texas. DMP projects are designed to translate evidence into practice and evaluate whether the practice change produces meaningful improvement. Statistics are a very important part of this process because they allow DMP prepared nurses to measure the outcomes objectively, meaning evidence-based. Infection prevention is especially important in healthcare environments where procedures may create opportunities for infection transmission, or AKA hospital-acquired infections. The project's reviews from this presentation focus on staff education, hand hygiene, because these areas closely align with my proposed DMP project and the medical spa setting. Applied statistics can be described as statistics in action rather than focusing on mathematical theory. Applied statistics uses data to answer real world questions and solve practical problems. In a DMP project, this means collecting and analyzing data to determine whether an intervention is producing the desired outcome. For example, statistics can help determine whether the staff compliance with an infection prevention protocol improves after education and implementation of a standardized policy. So basically, you put it in place, then you use applied statistics to go back to see, is it working or do we need to rethink this again? Applied statistics are important in DMP projects because they provide an objective way to evaluate project outcomes. Statistical findings can determine whether an intervention was effective or whether the observed improvement is meaningful. These results can also guide leadership decisions related to policy changes, staff education, and quality improvement. Ultimately, the goal is not simply to produce numbers, but to use data to improve patient safety, quality of care, and stability of evidence-based practice. Several statistical terms are important when planning a DMP project. The population is the larger group of interest, while the sample is the smaller group from which the data is actually collected. The independent variable is the intervention or practice change, and the dependent variable is the outcome that is being measured. The mean represents the average, while the median represents the middle value. Standard deviations describes how spread out the data is. Confidence intervals estimate a range in which the true value may fall. The p-value helps determine whether an observation difference is statistically significant rather than due to change. This slide provides an example of how I can use descriptive statistics in my DMP project. The data set represents staff hand hygiene compliance percentage: 72%, 75%, 80%, 82%, 85%, 88%, and 90%. The mean compliance rate is approximately 81.7. which represents the average performance. The media is 82, meaning half of the observations fell below this value and half fell above it. The standard deviation is approximately 6.5%, which shows there is some variations in staff compliance, meaning some people are doing it and some people are not. In my actual DMP project, I can compare compliance data before and after implementing the standardized infection prevention policy to determine whether the staff compliance improved and became more consistent. Hypothesis testing allows the project leader to evaluate whether an observation change is statistically meaningful. For my DMP project, hypothesis testing can help determine whether the improvement in staff infection prevention compliance after implementing the standardized policy is statistically meaningful. The null hypothesis would state that there is no significant difference in staff compliance before and after the intervention. The alternative hypothesis would state that the staff compliance improved after implementation. For example, if compliance increased from 72% baseline to 89% after 8 weeks and the analysts produced a p-value of 0.02, there would be below the commonly used alpha level of 0.05. Therefore, I would reject the null hypothesis and conclude that there is evidence of a statistical significant improvement in compliance. Several statistical problems can weaken a DMP project. A small sample size may limit the ability to detect meaningful differences. Selecting the wrong statistical test can lead to inaccurate conclusions. Missing data may also affect the reliability of the results. Another common problem is assuming that the correlation provides causation. Statistical testing also have assumptions that should be considered before analyzing. These issues can be reduced through careful project planning, constant data collecting, data validation, and consultations with statisticians when needed. The statistical test should match the type of data and project design. For continuous outcome involving two independent groups, an independent t-test may be appropriate. Also, when the same participants are being measured before and after an intervention, a paired t-test may be considered. ANOVA, ANOVA, is commonly used when comparing two or more than two groups. The categorical outcomes, chi-square, or Fisher's exact test may be appropriate. Pearson's and Spearman's correlation can examine relationships between two variables, while regression can be used when the goal is prediction or evaluating an influence of multiple variables. My proposed DMP project is focused on improving infection control practices in a medical spa setting through implementation of standardized evidence-based infection prevention policy. The independent variables in implementation of the standardized policy and dependent variable is the staff compliance with infection prevention protocols. Descriptive statistics can summarize compliance rates before and after implementation. If the same staff members provide paired pre and post intervention measurements and assumption for tests are met, a paired t-test may be used to evaluate the change. An alpha level is set at 0.05. In conclusion, applied statistics provide DMP leaders with a standard structured method for evaluating whether if practice changes are effective. Statistics support the translation of evidence into practice by helping clinicians measure outcomes, evaluate quality improvement efforts, and make data informed leadership decisions. For my project, careful selection of measurement instruments, constant data collection, and improvement statistical analysts will help determine whether infection prevention interventions improve staff compliance and support a safer practice environment in a med spa setting.